It used to be the back in the days that the Design Patterns book or the Gang of Four book from the 90s provided all the blueprints you needed for creating applications. But now, as more and more systems have become distributed, specialized patterns have evolved to help us follow the paved path. My name is Paul Balog, and I'm going to talk about one of these patterns, the Sidecar Pattern. So, what do you think about when you hear the word sidecar? Well, if you're anything like me, the name conjures up visions of the motorcycle sidecar, where multiple riders can travel together as a single unit, and even avoiding any possible awkwardness from being the one on the back of the bike. But if we take this visual and we apply it to the application with its sidecar, we end up with a diagram similar to this. In this case, the application or microservices tethered with its sidecar can collectively act as a single unit. So the pattern really has no restriction on the number of sidecars that can compose this unit, although a motorcycle having multiple sidecars may look a little bit odd. So ultimately, the sidecar pattern is for multiple processes to work together, acting as a single unit. Keep using unit quite a bit, but anyway. In Kubernetes clusters, the single unit is a pod. A pod can be made up of multiple containers, and in this case, the application is one container, and each sidecar is another. Now, these individual processes have the ability to communicate with each other on the loopback address. So basically, this just means that they can act as if they're on the same machine, addressing each other as a local host or the 127.0.0.1. Now, is this strictly a Kubernetes concept? Absolutely not. This concept could be applied to virtual machines or physical servers. If you think about it, really, sidecars are really just helper processes providing a multitude of services. Log forwarding, for instance. When you're running a single instance of an application, tailing the application log is no big deal. Expand that to a couple more instances, then aggregating logs to a single location is really the way to go. For this case, having a sidecar take away the burden of knowing how to forward the logs and to something other than sysout is pretty convenient. The same can be said for the metrics. Offload the application overhead from concerning itself with getting metrics to observability platforms like Prometheus or Grafana. Health checks and service discovery are other great uses. The sidecar can continuously check the state of your running application, ensuring that there's reasonable performance and to let others know where to access your service. If your application's under too heavy a load or in a bad state, the sidecar could deregister your instance so that clients can stop sending requests. A sidecar could possibly act as a cache of configuration that may change during runtime. It could act as an intermediary, possibly transforming messages coming from Kafka into a gRPC request. Really, the possibilities for what a function of a sidecar could perform is pretty much limitless. Now, let's take a look at some of the advantages provided by the pattern. So, separation of concerns. This allows for specialization. This actually frees up the implementation of the sidecar to be independent of the application. So perhaps the SRE team is maintaining a sidecar responsible for pushing metrics into Prometheus. The application team won't need to worry about any of the details of how or what is being collected. There's standardization. Similarly, that same sidecar implementation, pushing logs and metrics to your observability platform, can be reused for many applications, only differing based on the configuration. Resiliency. Sidecars can act as proxies, ensuring that downstream services are available and potentially providing a fallback response when things do go wrong. So, for instance, from a cache. So it could do things like acting as a circuit breaker, allowing a request to fail fast instead of waiting on a timeout. Autonomy, like we mentioned before, the implementations of the application and the sidecar are separate. So this allows us to use different languages or development teams. For instance, a sidecar could be written in Go, while the application may be written in Java. So it allows you to pick the right tool for the job. But it's not all rainbows and unicorns, though. Let's look at some of the negatives. Additional complexity. Yes, distributed systems are already hard, and breaking them down further makes it even harder. The sequence of startup was an issue that I can recall from Kubernetes. You may have race conditions where your sidecar hasn't been fully initialized yet and the application is already making requests to it, or vice versa. Latency. A function call within a single application process will always be faster than inter-process communication. And a larger blast radius. You remember that standardized sidecar that runs with many different applications? Well, what if there's a bug in that code that's going to affect a lot more than one single application? And the pattern is easily abused. Same as can be said with microservices in general. To be honest, you can see the pros and think everything should be in a sidecar, right? But it's really a bad answer. Always carefully weigh the pros and cons of each function. There's many horror stories out there where from Kubernetes that a pod contains 9 different sidecars. This is something that makes SREs cry. So in closing, I just want to say, when should you apply a sidecar pattern? Well, as with everything, it depends. Hopefully this quick tutorial gives you enough guidance that you can make an informed decision. And the producers of this video would like to note that no AI was harmed or used during the production of this video. Once again, my name is Paul Balog. You can find out more from me on LinkedIn or from my website at javaducky.com. Thank you very much.